this explanation that she's showing, she's doing an example of Santa and his sleigh. So right here, there's different types of forces going on. So down here where you see his feet, that is our action. So his feet have to push forward for the sleigh to move, right? And the reaction of that is that there's a force going that way, okay? So as he's going, there's a force that's going back too, okay? And same thing up here with his little rope that he has attached. There's an action going this way, and there's a reaction going back there, okay? So let's watch your explanation.
So the animal accelerates forward, and so does the sleigh. So one takeaway here is that there would be no Christmas without physics. But now we have an idea of some of the forces we might encounter. Let's describe what's happening when a box is sitting on the ground.
Okay, so that was the end of that video. Okay, so it talked about the first law of motion. Okay, so the first law said that an object stays at rest and an object in motion stays in motion with the same speed and in the same direction unless it's acted upon an unbalanced force. Okay, and it also talked about inertia. So inertia is the resistance of an object. So the resistance from an object that has a change in its state of motion or velocity. Okay, so this example right here kind of explains that. So we have a man who's driving in his car, right? But what's in front of his car? What do you guys see?
Brick wall.
A brick wall, okay? So what do you guys think is gonna happen if that man is going like 50 miles per hour and that wall is there?
He's gonna crash.
He's gonna crash, right? Now, if he is safe and he's wearing his seatbelt, will he possibly survive that force?
Mm-hmm.
Yeah. But what could happen if he wasn't wearing his seatbelt and that force was going and it stops right there on the brick wall? What's gonna happen to the man?
He would fly out of the car.
Yeah, he's gonna fly out, right? Okay, so it's basically saying that an object will stay at rest or in motion with the same speed unless it's acted upon an unbalanced force. So the unbalanced force right here is the brick wall. Okay, the car would keep going if the brick wall wasn't there, right? But it's gonna stop because that brick wall is there and it's gonna cause him to fly out and he's gonna keep going until he finally hits a breaking point. Okay, so that one is basically the first law of motion. Okay, and then this is another explanation of force. Okay, so force is basically a push or a pull that we like to describe it on an object that happens from an interaction with another object. Okay, so right here we see a force going on. Okay, so the interaction is between the boy and the box. Okay, this boy and the box. Okay, so if this boy is pushing the box, that's a force, right? And if this boy is pulling the box, that's another type of force, okay? So there's some interactions going on right there, okay? But when that interaction stops, what's gonna happen to the box? Ooh. It's gonna stop moving, right? Can the box move if we just leave it by itself? No, right? Like this furniture won't move unless I push or I pull it, right? So we don't have that interaction, then we don't have that force. It only exists as a result of an interaction, okay? But we have two boys here on opposite ends, okay? If this boy stops pulling the box, but this boy is still pushing, is there still a force going on? Yeah. And if he stops pushing but he starts pulling, is the force still going on?
No.
If he's pulling but he stops pushing? Yeah, right? What happens if they both stop? There's nothing, right? There's no force going on. Okay? But there's a force going on here and they're going here. But even though they are both doing that force, there are opposite forces. There's a pull and there's a push. Okay, and this one is the second law of motion that I also talked about in the video. Okay, so the second law is basically the acceleration of an object. So how fast something is going produced by a net force that is directly proportional. Okay, so proportional means the same to the magnitude of the net force that is going in the same direction as that net force and proportional to the mass of the object. So that one's kind of tricky. So basically it's saying the more force you put on something, the faster it's going to go. And the less force you put on something, the less acceleration it's going to go. Okay, so if I want to push this and I'm not able to, if I'm just going like this, am I going to push it as far as I want it to go? No, but if I go like this and use my feet, will it move a lot quicker? Yeah, so I'm putting more force, which is making it go faster. But if I'm doing less force, like this, it's not going to do very much, right? It's not going to move very much. Okay, so this is another example. And I tried to find a picture example of this, but it was kind of difficult to find a picture example of this. So I'm just going to show you guys another video about Newton's second law.
Let's suppose that you're writing a really important email to a colleague.
Okay. So there's Isaac Newton. Okay, so right there, he was trying to move the rock, but he didn't have enough force to do it, right? So what did he do to give him more force?
Drink an energy drink.
Yeah, he drank an energy drink to give him some more force, right? So by drinking that drink, he was able to push the rock and it was able to fall, okay? So that means the more force you give, the more acceleration it's going to give. So let's see. So here's like another thing that ties in. Why he's putting enough force and he's trying to do it, but why do you think he can't move that big rock?
It's not strong enough.
He's not strong enough. Yeah, and what else?
The rock is too heavy and big.
Yeah, the rock's too heavy. And when something is too heavy or has a lot of heaviness, what is that called? It has to do with matter.
Mass.
Mass, yeah. So the rock, who do you think has more mass? The rock or Newton?
The rock.
The rock, right? So that one has more mass, so where he's unable to move it. He doesn't have enough force to move it. He has to have an equal mass as the rock to be able to move it. So he only moves it a little bit. So what do you think is going to happen now?
He might use the horse.
He might use the horse. Let's see. Okay, so see, the force applied by the force causes the rock to move a greater distance. Why do you guys think the horse was able to do it, but not Newton?
Because he's stronger.
Because he's stronger, yeah. Who do you think has the bigger mass? The Newton or the horse?
The
horse. Horse, right? So he was able to get a bigger distance than that. So because he has less mass, he was doing a less force. And and the horse has more force, more mass, he was able to do a better acceleration. Okay, so just how we talked about, the mass of gluten is less, so the applied force is less. And the mass of the horse is more, so he was able to apply a more force onto the rock. So force is proportional to mass too. We need enough mass to get that enough force. Has to be equal. Okay, alright. So that was the end of that one. So that was the second law, and then our last law was the third law of motion. Oh, actually before I do the last law of motion. So these are just some misconceptions, some things that people get confused on about the second law of motion. Okay, so it said basically saying that sustaining a motion, so making sure that motion stays there, supporting them, requires a continued force. Okay, so basically it's saying forces do not cause motion, they cause acceleration. Okay, so if I move this, okay, the force isn't really causing the movement. It's how much acceleration I'm putting into it. Okay, so if I am going like this, I have to do it really faster for it to lift up. Okay, so basically force is not needed to keep an object in motion. We don't need that force to keep it moving. Okay, we basically what happens is there's a force of friction that happens. So this example here says, as a book slides across a table from left to right, like how we were showing in your video, it acts on the book to allow it to slow down and bring it to rest, right? So if we are pushing that book down, and you know how you guys saw that book stop, that's why it was able to stop. It was able to slow it down and bring it to a rest, so it wasn't moving anymore. Okay, so the third law of motion, for every action there is an equal and opposite reaction, okay? So there's something that's the same and something that's different, okay? So there's some interactions going on here, okay? So right here in this balloon, okay, he's holding up the balloon, so he blew it up, okay? But when he lets that balloon go, what happens to the balloon? There's two different actions that are going on. There's one, there's the action, the air that rushes down, and what's the other one?
The air goes down.
Yeah, the air goes down, that's the action. What happens up here?
It goes up.
Pushes up, the reaction, right? So it's pushing up, all that air is pushing up, but then the air is rushing down too. So there's two different things going on there, okay? So there's the equal reaction and the opposite reaction, okay? The other thing is, actually, finger on the wall. Let's try this on your clipboard. So everyone put their finger on their clipboard. Okay, so what you guys don't realize is that as you guys are putting your finger on your clipboard, there's two different forces going. It's the force of the finger on your clipboard and the force of your clipboard on your finger. Okay, so there you guys are pushing a force there, and that force is pushing back on you guys, right? If you guys go deeper, right, it starts to hurt, right? Your finger starts to hurt, okay? So it's a greater force, okay? And the other example is with a hammer and a wall, okay? So basically, the force is when you guys put a hammer on the wall. There's a force going on to whatever you're hitting, and the force coming back from hitting it, okay? So an action and a reaction. So on your guys' clipboards, you guys have a 3, 2, 1 sheet. Okay. So what I want you guys to do is I want you guys to think about and write down 3 things that you learned today. And that should be easy because you guys learned 3 different laws, right? 1, 2, 3. 2 things you found interesting about what you guys learned, and then 1 question that you guys still have. So once you guys are done writing that together, then I'm gonna do my clapping hands, and then you guys are gonna talk with each other about, actually you guys will do in pairs. So you and Leticia, and then you and Adara, you guys will talk about 3 things you learned, 2 things you found interesting, and 1 question you have. Okay, so you guys can go ahead and start writing that.